This is the beginning of section 6.4, Algebra 2. And it is logarithmic functions. We're going to start with a worksheet, work ourselves into some problems that have to do with logarithms. We started out this chapter with this type of function. F of x equals 2 to the x, and we learned to graph that. And this is basically y equals 2 to the x. Correct? You remember that? To do it very quickly, I'm just going to graph some points and show you where we're headed with that. If x is 0, we get 1. 2 to the 0 power is 1. If x is 1, we get 2. If x is 3 or 2, we get 4. So it looks like that, correct? All right. And it comes down, if you remember, it uses the x-axis as an asymptote. You remember that? Okay. So if we were to switch x and y, all right, how does that affect what happens to the graph? Well, let's put values down in for y.
So it never
and
touched
get back
the y.
for x. Now remember, we're putting values back in for x and looking for y. Maya, what'd you say?
So it never touched the y.
Well, let's see what happens. Okay. If we put 0 in for y, right? If we put 0, I'm going to kind of do a t-table here. If we put 0 in for y, what do we get back for x? We get 1. So 1, 0. Right? 1, 0.
That's 1, 1.
Thank you. Thank you. Yep, there's that Monday morning. Monday afternoon. What if we put 2 in for y? Or if we put 1 in for y? We get 2, right? So 2, 1. Okay. And if we put 3 in for y, what do we get?
8.
For x, right? So 8, 3. So 2, 3, 4, 5, 6, 7, 8, 3. Right? Okay. What would happen if we put in, let's try a negative 1 for y, which means 2 to the minus 1. What is that? 2 to the minus 1. Negative 2. 2 to the minus 1, which is what?
Negative 2.
No, it'd be 1 over 2. Remember what a negative exponent means. Okay, so if we go 1/2, we get a negative 1. What's it doing? It's exactly what Maya said, isn't it? It's coming down like this, and it's going to the y-axis. Is that what you said, Maya?
Yeah.
Okay, so look at it. Look at the two graphs next to each other, right? They are actually a reflection over this line, aren't they? If you reflected it, it would match up. In other words, if we switch the x's and y's, remember this point was 0, 1, this is 1, 0. If we flip the x and y, do you remember what we call functions in which we flip the x and y and they match each other? They are reflection, but we call them inverses. They are inverses of each other, correct? All right? Do you see that? All right. Well, if you look on page 397, they show that on there. And it says in x equals b to the y, the variable y is called the logarithm of x, and that's where we're going today. So, in other words, we could write y if we go x equals b to the y, okay? If that is the case, if x equals b to the y, then y equals the logarithm of x base y, base b, excuse me, base b. Okay? These two are the same. This is the exponential form of it, and this is the log rhythmic form. All right? Now, that is the last time you'll see me spell log, probably, or logarithmic. Okay, we will use the term log, but these two are the same. So if we graph this one, this is what it is. B to the y power equals x. Let me say that again. B to the y power equals x. That's how we get that. Okay? So if I give you a logarithm, such as, here's the log, here's the exponent. All right, we're going to go from back and forth. So if I give you the log of 8 base 2 equals 3, how do I write that in exponential form? I don't want to change the equivalent of it. I just want to write it in exponential form. Why is this on the...
Yeah.
Okay.
8 equals
8 equals
2 to the 8.
2 to the
third.
third power. And isn't that a true statement? Or I could put 2 to the third power equals 8. Either one, correct?
Yes.
Okay, that is a true statement, is that we know that 2 to the third power equals 8, okay? You'll notice that the logarithm does a couple things, all right? The base 2, this is read, the log of 8 base 2 is equal to 3. The base on both of them is the same, isn't it? All right, and it isolates the exponent. It isolates the exponent, and that's what the logarithm was meant to do, was to isolate the exponent. All right, let me give you another one. What if I went the log of 1/10 base 10 equals a negative 1? How would I write that in exponential form?
Negative, or 1 to 10. 10. 10 to the negative 1
Say that again.
equals 10 to the negative 1 power.
Equals 10 to the minus 1 power. Okay. All right. Could I say 10 to the minus 1 power equals 1/10? I always go like this. 10 to the minus 1 power equals 1/10. Right? How about this one? The log of 1 over 256 base 4 equals a negative 4. Write that in exponential form. Brian? 1 second.
So it'd be 1 over 256 equals 4 to the minus 4 power.
Okay.
4 to the 5.
Okay. All right. So if you look at your worksheet, it says on 1 through 4, rewrite each in exponential form. Can you see that on there? Is it close enough?
That's close enough.
Okay. All right. And so let's do the first one. Why don't you do the first one?
Do you want us to do these on a separate piece of paper?
No, you can do it on the worksheet. Okay. Emily, what did you get for number 1?
36 is equal to 6 to the second power.
Okay. All right. Now, what I'm going to do is I'm going to give you it in exponential form, and you're going to write it in log form. So, dog to the tree power equals almond. Dog to the tree power equals almond. All right, how would you write that in logarithmic form? The log of what? The log of almond, she says.
And base dog.
Base dog?
Yeah. The
base dog
equals tree.
equals tree. Okay? So dog to the tree power equals on. Okay? Now you do this one. 5 to the minus 2 power equals 1 over 25. 5 to the minus 2 power equals 1 over 25. Maya?
So it'd be log 1 over 25 base 5 equals -2.
Did everybody see that? Okay, so the front page is just going from one to the other. Okay? Alright. Alright. And actually, 1 through 20 is that way, isn't it?
Yeah.
Alright. Now, you'll notice that you have to evaluate. So, if you look on the back page, it says evaluate each expression. Okay? So we can evaluate logarithms, but you gotta keep in mind what they are. Alright? So if we look at number 6 on this example, if I say the log of 125 base 5 equals what? What am I asking? What am I asking?
What is 5, what power does 5 have to go to get 1?
Alright, so what power is 5 that equals 125? 5 to what power is 125? 3. 5 times 5 is 25, times 5 is 125. Okay. Let's try this one. The log of the log of 8 base 64, okay, equals what? Now this one's a little trickier. It means what?
Fraction,
It's a fraction. Well, explain that to me.
because it's bigger than 8. 8 is the perfect square root of 64.
8 is the perfect square root of 64. 64 is the base, isn't it? So it's 64 to what power is 8? Well, it's the square root of 64, so what power is that? Not the second.
4.
The 8. 1/8.
Doesn't square root and the 1/2 power be the same? Now take a look at it. If I turned it around, I'd say 64 to the 1/2 power equals 8. That means the square root of 64 equals 8. Is that a true statement?
Yeah.
1/2, so 1/3 power would be the cubed root, right? Right? So let's try to create one of those, all right? The log of 3 base 27 is what? Is what? 1/3. Now we can also have negative exponents. Are you okay, Maya?
Kind.
Well, if I take 3 times 3 times 3, I get 27.
Yes.
So it'd be the cubed root of 27.
Okay.
All right? But I can also have negative exponents. For example, if I take the log of 1 over 64 base 4. Okay? Now, how many times does 4 times itself equal 64?
3.
3 times. 4 times 4 is 16, times 4 is 64. And so it would, normally 4 to the 3rd power would be 64. Only the 64 is in the denominator.
So it would be -3.
It would be a -3 Because 4 to the negative 3 power is 1 over 64, or 1 over 4 cubed. Do you see that? All right, so let's try another one. The log of 1 over 300, can't do it in my head, 343 base, no, trying to do it in my head. Let me grab a calculator real quick. Shows you how much good my brain's working today. Yep, that's right. That's right. Okay. 1 over 343 base 7. Lila? 7 to what power is 1 over 343?
-3.
Negative 3. Very good, Lila. Maya, do you understand that? Okay. How about this one? The log of 1 base 9 is what? The log of,
0.
it's 0. Okay? It is 0. Okay? It is 0. All right. Now I'm going to have you memorize, and I don't know if this rule is in the book. Okay. If this rule, and I'm trying to remember how it was, the x to the log of y base x equals y. Okay? Whenever you have x to the exponent of log of y base x, it equals whatever that value is. So if I have this type of problem, the 7 to the log of 23 base 7 is what?
23.
It is 23. Okay? And that is a rule, and your book doesn't do it, it's in the old ones, but the last 4 problems are based on that concept. So, all right? It's not something that you'll see a lot,
Okay.
but you'll see once in a while.
So
Okay?
it's always the what? So it's
Yes.
always the.
It's always what's the y. And that's, in my old book, that's not the way they had it, but that's as close as I mean, they had it with different letters, but I can't remember what they were. So, okay? All right, do you have any questions about that? All right, this worksheet is due when? Monday. Would you please get it done before you leave? Okay? All right, you shut.
Uh,